Welcome back, students. So in this video, I want to go ahead and address this idea of transferring of energy, or how does the energy get transferred in the first place? Well, in a previous video, we had talked about how enthalpy was equal to the energy plus the product of pressure and volume. And so we went through and explained that energy was really just more this concept of stored energy, which it was encapsulated in this idea of the sum of potential energy, kinetic energy, and this internal energy. All of those items together is what we call this energy. And then we also use this equation over here at the very end, where the energy is equal to this heat component plus the work that is able to be done. And so we explored how work was developed in the previous video, and it essentially had to do with a force being applied over a certain distance, or in our case in chemistry, it was going to be this idea that work was essentially equal to the negative pressure times the change in volume. Now, in this particular video, we want to kind of take a look at, now that we know what energy is, how do we consider how it goes from one object into another object? And so the idea here is, let me just move this out of the way. So the idea is that when you consider this concept, we need to make sure that we understand that there's really three ways that energy is going to be transferred. And so here, what I'll do here is I'm going to say here there's three ways that this can occur. And the very first way is known as conduction. And so conduction is essentially that transfer of energy that occurs with solids. Okay. The second one, or second method that energy is transferred, is this notion of convection. And so you may be familiar with the general term of convection ovens and stuff like that, and convection current out in the oceans. And that's largely because convection is essentially going to be a form of heat transfer that involves gases and liquids. And then lastly, the third method by which energy is transferred, and this is known as radiation. And we've already explained radiation in terms of frequency and wavelength, but here when we talk about radiation, in line with that previous discussion, we're talking about heat transfer that involves electromagnetic waves. And so I'll abbreviate that as EM waves. And so just to be clear here, EM means electromagnetic. And so these are the three ways that it can occur. And so here, let me just say here, specify this is going to be related to heat transfer. And heat transfer can occur by any of the three ways all at once. And you can have maybe two forms of the three being utilized to transfer energy. You can have all three of them, but rarely are you going to find just one of them being the only method by which transferring of energy can occur. And the other item that you need to be aware of here is that when we talk about this concept here, let me just move this a little bit, is that energy transfer is always going to occur from a high concentration to a low concentration. This is always going to be true, and this is going to be very consistent, a very consistent principle across science, whether it's biology, physics, or chemistry. It doesn't matter. We're always going from a high concentration to a low concentration. That concentration gradient is what allows that transfer to occur. If there was no concentration gradient, like many items, especially when you consider things like electron flow, there isn't going to be any kind of electrical flow or conductivity that's going to occur. The same thing with energy, or in this particular case, heat, as a proxy for that kinetic and potential energy, is not going to transfer from one object to another. And this is going to continue. This transfer is always going to continue until you reach one point, and this is when you reach thermal equilibrium. And I'll just abbreviate it like that. And so transfer of heat is always going to occur from high to low, and it will continue to transfer until the two objects involved are going to reach this thermal equilibrium, in which case the object 1 is going to have a very similar temperature as object 2, and therefore at that point, when thermal equilibrium is done, there is no longer any heat transfer. Okay, so those are important concepts here in terms of how energy transfers. And so we'll go ahead and cut the video here at this point, but if you haven't had a chance to subscribe, please do so. Keep watching, keep learning, and we'll see you in the next video.